Hello students, let us see this question. This question is very simple but very conceptual. So see what this question is. All the resistors in the circuit below have the same value. If an emitter is placed in the circuit in turn at point A to E, which of the following set of points will give the same reading? So your options are A, B, C, D, and various points are written here: A, B, A, C, B, E, C, D, and A, B, C, like this. So in this question, we have no any value given. There is no any exact value of voltage or resistors. The only one information we have is all the resistors are of the same value. So we can assume that all the resistors are of the same value as R, right? And then we have to see where the reading of the ammeter will be same. So please see how we can solve this question. So for this, we should know the current division rule. We must have the current division rule, right? So what is the current division rule? See, if you see your Ohm's law, in the Ohm's law, right? See, where my current will be different. Obviously, my current will be different in parallel circuit. In the series, current will be always same. So we don't have to divide the current. The current will be always the same and as it is flowing in the branch. So in the parallel connection, we have to divide our current where which current will pass, how much current will flow through any part, any branch of parallel circuit. So in the parallel, we have the current, we have to divide the current, and in parallel connection, the voltage is same, V is constant. So basically, I and R are inversely proportional for a parallel circuit. It means where resistance is high, current will be low, right? Or we can say the famous tagline, that is, the current takes the shortest path. Current will take that path in which the resistance will be less. Okay, so let us try to visualize this situation. In this parallel connection, what is the R equivalent? It is the R by 2. When we have two equal resistors connected parallelly, the equivalent will be get divided by 2. Similarly, here it should be R by 4. And what should be here? See, the this is R and this combined should be 2R and this should be 2R. And if we find the combined equivalent resistance of this parallel branch C to D, it should be R parallel with 2R parallel with 2R. This 2R will give us R. As I told you, when equal resistors are connected in parallel, they get divided by 2 if they are 2 in numbers. If they are 3, they will divide by 3. So R and R again parallel, you will get R by 2. So they have R by 2. Okay. Suppose my current is flowing in the circuit from the beginning. So if we apply our current division rule, obviously in the first circuit, in the first branch, it will get equally divided, I by 2 and I by 2, right? It will get divided equally as I by 2 and I by 2, right? I by 2. So in A point, ammeter will read as I by 2. And here also it will be I by 2. And at this point, again, they combine and give us I. Now again, they have to be divided since all the resistors are equal. So in each and every branch, it will get divided equally. So I by 4 current will pass through each of these parallel part of this circuit. In each branch, it will be I by 4, right? Again, at this point, they will get combined to give I. Now, we have to apply the current division rule in this third parallel branch, right? So, in the third parallel branch, you can see there is R, 2R, and 2R. And the parallel of this 2R and 2R is R. Let's see. This is R, this is R, this is 2R, this is 2R, right? And I current is coming, right? So what will happen? See, the combination of this 2R and 2R is again R. So you can think in this way. This is the R, this is also R, right? And I current is flowing, right? This is the resistor A, suppose this is the resistor B and this is the resistor C. This R is the equivalent of B and C. So what will happen? This I current is coming. So since both the resistors are equal, so they will get divided equally, I by 2 and I by 2, right? So in this branch, in the A resistor, it will get I by 2. In this parallel combination of B and C, see I by 2 is going there, but again they have to be divided equally. Why? Because they are equally value. So in these two are resistors, they will get divided equally. So I by 4 and I by 4. So at this point again, see this I by 2, I by 4 and I by 4 becomes again I. It means in this resistor, the C point, the ammeter reading will be I by 2. And this A point also the ammeter reading was I by 2. So I think this A and C will have the same ammeter reading. So obviously this option B should be correct. You can check any other point. See, A and C have also it is mentioned that A and C. So let us see the B point. Obviously at the B, the emitter reading will be I by 4, not I by 2. So I can eliminate this option. So I will have only one option, that is option B. So it should be our correct answer. So I hope you have understood this question. There will be this kind of conceptual question in your paper. So please focus your fundamental concept. I will upload other questions also that will be conceptual and helpful for your examination. Thank you. Thanks for watching.